Alright, let's look at an example where a power series method fails to produce a solution. Alright, so here's an example. X squared y prime plus y equals 0. Alright, you probably noticed that this is a separable equation. So let's first solve this using the old method separable equation here. Alright, so this is going to be, alright, so we have to separate them. First, I'm going to subtract y. So we have x squared y prime is equal to negative y. Alright, then I'm going to divide through by y, and also I'm going to divide through by x squared. Alright, so we're going to get 1 over y because we're dividing through by y. And I'm going to write the y prime as dy over dx. Alright, so you have a negative 1, but we're going to divide by x squared. So I'm going to write it as a negative x to the negative 2. Alright, then I'm going to integrate both sides with respect to x. So we have integrate here with respect to x. Alright, so we can cancel dx here and dx there. So we have, so 1 over y, so antiderivative 1 over y. And the antiderivative 1 over y is natural log of absolute value of y. Alright, so this is equal to, right, antiderivative of that is negative, and add 1 to the power, so it's negative 1. Then we have to divide by that power, so negative 1. And plus some constant, I'm going to call it the C1. Alright, so negative signs cancel out here, so we can cancel negative signs. Alright, so let's, since I have to, I want to isolate the y, so I'm going to get rid of natural log. So I'm going to raise e to both sides. Then you end up with the absolute value of y is equal to e to the x to the negative 1. I'm going to write it as 1 over x and plus c1. Alright, I'm going to split this as e to the c1 times e to the 1 over x. Alright, and then I'm going to remove the absolute value sign so that y is equal to plus or minus, you have e to the c1 and times e to the 1 over x. Alright, so since you have a plus or minus e to the c1, it's just going to be a constant. So I'm going to call this constant just c. Alright, so therefore we have this solution. Y is equal to constant c times e to the 1 over x. Alright, so this is the solution of the differential equation. Alright, so let's apply power series method to this same differential equation and see what happens. Alright, so here we're going to get, let's see. Alright, so we have x squared. Alright, so y prime is a summation. N goes from 1 to infinity. N Cn x to the n minus 1. Alright, plus, alright, summation, alright, n goes from 0 to infinity, Cn x to the n. And this is equal to 0. Right? So what I'm going to do is I'm going to actually put the x squared inside here. and I combine it with the x to the n minus 1. So I guess we just have to change that to, instead of n minus 1, we have x squared, so it's going to be n plus 1, right? So what we're going to do is I'm going to have to, let's see, get the x to the n instead of x to the n plus 1. So what I'm going to do is this. All right, so I'm going to do a summation. All right, instead of starting from 1, I'm going to start with the one larger number, so n equals to 2 to infinity. All right, since it starts from a one larger number, so I'm going to have to reduce the index by 1. So n becomes n minus 1, and the Cn becomes Cn minus 1. Then x to the n plus 1 becomes x to the n. Right, then we have this guy, so it's a summation. Oh, actually, maybe I'll do one more step here. So this guy starts from n equals 2. So I'm going to actually pull the first two terms. Very first term is C0. And next term is C1x. Right, so that we can start from summation. N goes from 2 to infinity of Cn x to the n. All right, so this is equal to 0. All right, so we got that. All right, then what we do is I'm going to just put these summations together. So we're going to end up getting this. All right, we're going to have C0 plus C1x plus summation n goes from 2 to infinity. Right, then we're going to have n minus 1, Cn minus 1, and plus Cn. And then I'm going to pull x to the n outside, and this is equal to 0. All right, so here, so this would imply that here, right, C0 must be 0, because there's no constant is 0 there. All right, there's no x term here, so C1 has to be equal to 0, right? Then from here, by setting this coefficient equal to 0, we get this condition. We know that, let's see, Cn is equal to, I'm going to put this on the other side, so it's going to be negative n minus 1, Cn minus 1. All right, so if you want to find the C2, that would be, all right, if you want C2, so it's going to be negative 1 times C1. But the C1 is 0, so it's going to be 0. All right, C3 is going to be negative 2 times C2. But the C2 is 0, so C3 is going to be 0. So you can see that it's all Cn in this case is going to be 0. All right? So therefore, since all the coefficient is 0, the only solution you get is y equals 0. So you only get a trivial solution. All right? Instead of the solution, which is supposed to be y equals a constant times e to the net 1 over x. All right, so this is an example where power series method fails to produce a non-trivial solution. All right, that's it. I hope that this was clear.